Hello everyone, welcome to this channel. Today we are going to collect Physics Ordinary Level National Exam 2019. Yes, this exam has three sections: Section A, Section B, and Section C. But we are going to begin from the question which has more marks. That's why we're going to begin from Section C. Yes, we are going to begin from Section C. So please subscribe to see section B for next. Thank you. Let's go.
Hi, hello, ladies and gentlemen. And now we are going to collect National Exam 2019. Here we go. Yeah, as you see, we are going to begin by deciding order from the question which had more marks up to section A from the question 1. As you see, we are going to begin with section C. This is questions compulsory, which means that you have to do it. It's obligation to do these questions and have 15 marks. 15 marks. Here we go. Question 21. A student carried an experiment in order to determine the electromotive force E of a dry cell. The result was as follows. You see here there's resistance, the symbol is R and the unit is ohm. Here's the current where the symbol is I and unit is ampere. This is 1 divided by current where its symbol is 1 divided by A and the unit is ampere per minus 1. As you see, those are the results of the resistance, and here's the results for the current. The first questions: copy and complete the table below. Include only resistance and the current as the unit of ampere. Round off to one decimal place for the example 2.1 and 3.0. Next question: plot a graph 1 divided by a vertical axis on against R on horizontal axis and draw the best fit line. C. Determine the slope S. Determine the slope S. How to determine the slope? And number D, which is last, determine the value of E given that E is going to be 1 divided by S. Remember that S is the slope. Interpret your result. Okay, back to our question. You see that the first question is copy and complete the table above. We are going to complete this table. You see, this is 1 divided by current, and here there is current, so that we have to take 1, we divide by this value that we have given. Yes, we go. Let us try the first one. Let us try the first one. This calculator, we are going to take 1 and then we divide by 0.38 and 5. Yes, as you see, the answer is 2.59, but we can round off and it can be 2.6. Yes, it can be 2.6. Yes. Next one, we're going to take 1, we divide by this value. 1 divided by this value. Yes, the result is going to be, let us try. Yes, we're going to take 1, then we divide by 0.25 and 0. The solution is going to be, as you see, it's 4. Yeah, it's 4. Next point, we are going to take 1, we divide by this value. 1 divided by this value, let us what we're going to see. Take 1 and then we divide by 0.200. As you see, solution is 5. Solution is 5. Yes. Next step, we are going to take 1 and divide by this value. 1 divided by this value. Let's try using our calculator. It's going to be 1 divided by 0.15 and 0. The solution is going to be 6.66. By rounding off, we're gonna find 6.7. That's the value we are going to Fine. Next one, we are going to find 1 divided by the next value, which is 0.125, as the formula is 1 divided by current. We go. I'm going to find 1 divided by 0.125. The solution is going to be 8. Wow, I've seen 8. This is the solution. Next step is to take 1 you divide by this value. 1 divided by this value. Here we go. Let us say 1 divided by, I'm going to divide by 0.100. Solution is going to be 10. Wow. As you see, those are the results we have found: 2.6, 4.050, 6.780, and 10. Those are the results we have found as we did the calculations. Next question is B. Prove the graph of 1 divided by ampere, which is 1 divided by current, along the vertical axis known as y-axis against a resistance R on the horizontal axis known as x-axis, and draw the base fit straight line. Here we go. So we are going to prove. As they have said, those value 1 divided by current, they are going to come on y-axis. Those values are going to come on the y-axis, and the one for resistance are going to on the x-axis. Yes. Let us see our graph. Let us see. You see here, this is our graph. As you see that the resistance along the x-axis and 1 divided by current is along y-axis. The first point is 2.6 and 2. As you see, these along 2.6. The next one is the 4 and 4. As you see, the 4 and 4. The next one is 5 and 6. As you see, let us see, this is 6, this is like along 5, yes, and so on. As you see, we are going to find this best fit straight line. You see, yes. We are going on section C, which is determine the slope S. And you know how we calculate the slope is the change along y-axis divided by the change along x-axis. Let's go. Yes, we are on C. We are going to find the slope. As you see, for y-axis there's 1 divided by current, while for the x-axis there is resistance. So the slope is going to be the change of 1 divided by current divided by the change in resistance. So I'll take 2 points. The first point is here. They have a y1 or the along y-axis, which is 4. They have x, what we can call as x1 for x-axis, which is 4. The next point is this one. They have 8 here. They have to have 10. So that's why we are going to the change in y-axis 8 minus 4. Change in x-axis is 10 minus 4. You get 4 divided by 6. Get 0.667. The unit is current power minus 1 ohm power minus 1. Yes. This is our solution. Next point is determine the value of E given that E is 1 divided by slope. Interpret your answer, your result. Determine the value of E given that E is equal to 1 divided by S, and we know that S is our slope, and we have to interpret our result. Yes, as you see, our D is E, which is 1 divided by S, and our S is our slope, and our slope is 0.667. So we have to take 1 with the divided by 0.667, and the solution is going to be 1.5 ampere or ohm. This is our result. Back to our question, they say, and interpret your results. So you are going to interpret. as we have found along the result is 1.5 ampere ohm, but we know when you take ampere divided by ohm you get the voltage or EMF. As you see, our EMF is going to be 1.5 voltage, and as the interpretation may say that is the result is reasonable because the new dry cell has an EMF of 1.5. Try to look at the new dry cell, the new one. The value of EMF is 1.5. So this is equal to our result that we have found. So we have found the true solutions. Thank you very much, ladies and gentlemen. See you next time when we collect the section B. Yes, if you like this video and you want to follow about the section B, yes, you have to click the button of subscribe and share to your friend. And we correct the whole exam of 2019. Yes, thank you very much.